Pascal's triangle is another way of helping us to figure out the coefficients of binomial expansions. It's actually kind of cool. If you look at the triangle, it's formed by building on the fact that if we take, we start off with the 1 at the top and then 2 more 1s. And then from there, everything is the sum of what's above it. So if I look at this position here, between these two 1s, 1 plus 1 is 2. Okay, if I look at this position, I've got 1 above it and 0, it's 1. There's always going to be 1s on the outside. Okay, so I'm going to start, the next row is always going to start with a 1, because there's only a 1 above it. The next position has a 1 and a 2 above it, so it's going to be 3. We have a 2 and a 1, 3, and then just the 1. Okay, 1, 4, 6, 4, 1. And you're just adding. Okay, so if I pick any number in the triangle, 15 is the sum of the two numbers directly above it, 5 and 10. 70 is the sum of 35 and 35. Right? So you can build this triangle as large as you want or as large as you need. Here's how we use it. If we are expanding out, okay, we have a plus b raised to the 6th power, we're going to look at the triangle. We're going to find the row that has the 6 in the second position. Essentially, it's the 6th row of the triangle. 1, 2, 3, 4, 5, 6 is the next one. Okay, we're not really counting that first one because it's not a binomial. We're going to use this row, and these are going to be the coefficients of our terms of the expansion. Now, remember, when we expand, we're going to start with the first variable is going to start at the highest exponent, which is going to be 6. The second variable is going to start at 0. So if we want to build this, I'm going to create 1, a, b, and I'll put the exponents in later, plus, next coefficient is 6, a, b, plus 15, a, b. Okay, next number is 20, plus 20, a, b. Again, I haven't put any of the exponents in yet. Plus 15, a, b, plus 6, a, b, plus a, b. Okay, it's just a 1. Okay, you can put the 1 in there if you want. Okay, let me change colors now. I'm going to go ahead and put my exponents in. The exponents work really easy. I start with the first variable, which is a. It's going to start with the highest exponent, which is going to be 6. So that gets a 6 there. And then I decrease the exponents of a on each successive term. So 4, 3, 2, 1, 0. No, a to the 0 is just 1, so that's really going to cancel out. Okay, now looking at the b, we're going to do a very similar process, except we're going to start at 0, so that's b to the 0, which cancels, b to the first, b to the second, b to the third, fourth, fifth, and 6th. Then I could simplify this if I want. So this is just going to be 1a to the 6th, b to the 0, just a to the 6th, plus 6a to the 5th, b to the 1st, or just b, plus 15a to the 4th, b squared, and so on. Okay, so the Pascal's triangle gives us these coefficients that we need. Okay, so let's use Pascal's triangle to expand g plus h to the 4th. Well, we're going to use the row in the triangle that has the 4 in the second position. Okay, so this is going to be 1, and I'm going to put g and h in there, plus 4, g and h, plus 6, g and h. Haven't put in any exponents yet. Plus 4, g, h, plus 1, g, h. Now let's go ahead and put in our exponents. Okay, we're going to start with the highest exponent is 4, so it's going to be g to the 4th. H we'll do later. 3, 2, 1, 0. And h is going to start at 0. 1, 2, 3, 4. Right? So this g to the 0 cancels, h to the 0 cancels, and let's just write this out now as g to the 4th plus 4g cubed h plus 6g squared h squared plus 4g h cubed plus h to the 4th. That would be your binomial expansion rather than doing all with a foiling and multiplication.